Okay, the segment addition postulate, the angle addition postulate, the midpoint and bisectors and distance. Segment addition postulate refers to a segment that's in pieces. It has 3 letters or more on it, and we can say that the pieces of the segment will add up to equal the whole segment. In other words, segment AB plus segment BC will equal AC. If AB is 5 and BC is 15, when we add AB and BC, we'll get a total measure for AC. We substitute the 5 for AB plus the 15 right underneath the segment BC. Equal signs line up, and underneath AC we have the total 20. The angle addition postulate, denoted AAP, is very similar. But remember, when we're naming angles, we will use 3 letters. The middle letter is the vertex of the angle. So we have a ray SP bisects, or is in the middle of, angle RST. So we have angle RST is cut in 2 pieces. So angle RSP plus angle PST will add up to angle RST. We can add angles just like we add segments, just like we add numbers. Now if RSP is 30, we can substitute the number 30 right underneath angle RSP, plus this substitute the number 40 underneath PST, and when we add them up we get the measure of angle RST, which is 70. And of course when you write angles you're going to put the degrees. Now we have a line. Line L is a segment bisector. We're going to find EG if EF equals 13 centimeters. So we know that EF equals EG because L is cutting it in half. Bisecting means it's cutting it exactly in half. So we can write the segment equality statement. The measure of EF equals the measure of FG. If we know that EF is equal to 13, and EF equals FG, we can say substitute 13 for EF, and we can substitute 13 for FG. So EG is the sum, 26. Now let's use it again, and this time we'll have an algebraic equation because there's a missing or unknown part. You want to state your answer each time and box it. The next example, we're looking for JM if M is the midpoint of JL. Again, we have an exactly in the middle point, so JM equals ML. We want to find JM, and we're given 2 algebraic expressions, 6x plus 7 and 4x plus 5. We know by the segment addition postulate that JM equals ML. JM is represented with 6x plus 7, and ML is represented with 4x plus 5. Now we can solve this equation by substituting 4x from both sides, which gives us 2x plus 7 will equal 5. Next, we're going to subtract 7 from both sides, and that will leave us with 2x equals a negative 2. The last step in solving equations, of course, is to divide by the coefficient. In this case, it's a 2. When we divide both sides by 2, we can see that x equals a negative 1. We're not quite finished. There's a very common mistake. People will stop right there. You want to make sure you substitute that value of x back into your expression for Jm. Since Jm is 6x plus 7 and x equals negative 1, we take 6 times negative 1, and then we add 7 to it. We'll get the measure of Jm. So we have a negative 6 plus 7 will equal 1.